Okay, let's take a look at linear insertion sort algorithm. So I've got a lot of components that are already designed in here. So they're from previous programs that I've written. So if you've been following along, you probably have these somewhere, or you can create them as we go. So the first one here is a print nums method, which is just designed to print the numbers in our array from 0 to 99, and I've got this to handle anything that is a 1-digit. So if you need, pause the video and you can include this into your program. The second element that we are going to include from a previous program that we've written is this insert method. So what this is designed to do is it's designed to take an array, take a value, and say what position in the array to insert that value. Now, if you need to pause the video to copy this down or include it from some other program, please do that now. So the thing that this is missing that we kind of need is this is designed to insert something in between a chunk of data and another chunk of data. However, it doesn't really handle how to put something at the end of an array. So what I'm going to do is I'm going to include a totally separate method for handling that. And I'm going to do a little copy paste. So we're going to make a second copy of insert. But the only thing we're not going to need is the position from here. So this one is going to be designed to insert an element at the end of an array. Okay. So let's take a look at how we're going to do this. So we still need our new array here. Now, we don't have position to work with anymore, so I'm just going to go with the array.length here. And then what we're going to do is we are going to simply copy things over. And then what we're going to do here is put in. So because this is larger than the original array, what we can do is we can take the position of the end of that array, or sorry, the length of it, and then use that as a position in our new array here. And we don't need to include this section here where we are putting on whatever's afterwards. So pretty much we're copying it over and then we're adding in the value as the last element. So this is going to be very useful. Okay, so now down to our main program. And again, I've already got some components included here. So with this one, we've got an array with 15 elements. We're going to create 15 random numbers from 0 to 99. We're going to print them. This step here is where we're going to do our sort, and then we'll get the final result at the end. So I'm just going to run the program and explain what we're going to be doing as we are doing a linear insertion. Okay, so the way this is going to work is it's going to take one element at a time from the original array and then put it into a sorted array. So the only step that's a little bit different is the first step, where we're just going to take whatever the first number is. The reason that this is different is because we don't have to figure out where to put it in the destination array. We're just dropping it in. 63 is going to be the first sorted value. If you only have one value, it is by default sorted. And then what it's going to do is it's going to take the 35 and it's going to decide, okay, does that go before the 63 or after the 63? So it's going to decide that it goes before. So we're going to get 35, 63 is going to be our new array. Then it's going to take the third one and it's going to go through the array trying to figure out, okay, now where does this fit in? So it's going to insert it in between the 35 and the 63. So our sorted array then will become 35, 49, 63. It'll add the 92. 18 will go at the beginning. 0 will go at the beginning. So what it does is it just collects one element at a time and then inserts it into the correct place. So because I want to do I want to construct an entirely new array, what I want to do is I'm going to return that array to the main program once it's been constructed. So what I want to do here is a little bit of a different function call than the last program. We're going to return. We're going to return the resulting array, and then it will be in sorted order. Okay. So let's go create this. All right, so public static integer type, because we're going to be returning, integer array type, because we're going to be returning the array. And I'll call this insert sort. And of course, we are receiving the array as our initial piece of data. Okay. Now we're ready to make it. So I'm going to, again, we're going to be with a linear insertion. Typically you create a new array, although you can do all of the work within like one existing partitioned array where there's like a sorted part at the beginning and the unsorted part is the end. But this one's a little bit easier to program, so we're going to do it this way. So our new array, this is the one we're creating, is going to be a new integer array. Now, how many elements are going to be going into this? 1. What we're going to do is we're going to create it with one space, and I'll show you why here. We're going to start this. Oh, you know what? I'm going to put in also new value. Now, you don't technically need this, but I find that the program is maybe a little bit easier to read. So if you're unfamiliar with what's going on here, the new value will be helpful. So we're going to do the first part of the sort right here. So the first part of the sort, we're going to make the first element of our sorted array is going to be equal to the first element of our original array. So what I've done is I've created an array with size 1 that I know is sorted because one element is automatically sorted. So we've got our first element. Now we're going to need a for loop to handle the rest of this. Okay, so what part of the original array do I still have to sort? Well, the first element is already included. So instead of starting at 0, I'm going to start at 1. And then I'm going to go while I is less than array.length, because I do want to obviously sort every element that's in that array. Okay, so this is going to be our for loop. We're going to go from position 1 all the way to the last position, and this should be familiar notation by now. Now, what we're going to do is every time we go through, we're going to take our new val, and we're going to make it equal to array element I. Now, again, you don't need this. You could program this with just array element I, but for people who are having a little bit more difficulty sort of seeing what's happening with all of these arrays and their elements that we're referring to, creating a variable that is just specifically, this is the value that I'm going to be adding to the sorted portion, will make it pretty easy. Okay, so now what is the sorted portion of our sorted array? So the sorted portion is always from 0, because the first position is already sorted. But how much of a sorted array do we have? Can we tell this? Well, we are about to put in element I. So I've got everything sorted before element I. So this is essentially always going to go from 0 to I minus 1. And then what we're going to do is we're going to either insert it somewhere in the middle or tack it on at the end. Okay, so we've got to write a for loop here that's going to go from 0 to 1 less than I. So we're going to make another for loop here. So we're going to go, we're going to call it J, which is pretty typical for a for loop inside of a for loop. And we are only going to be busying ourselves with the sorted array here. So I is going to kind of refer to the original array. J is going to refer to the one that's the portion that's already sorted. Okay. Now, how long do we go? We go until we're less than I. So J is going to keep going until up to, but not including I. And then we'll do a J++ here. So this traverses the original array. So traverses original. And this traverses the sorted part that we've got. Okay. Now, what we want to do is, oh, I don't trust this. Why did it? Okay, anyways, I'm better now. So what we want to do is this array is to, or this loop is to determine the location to insert new val. So it's going to creep through the sorted portion that we've got and look for the place that we should be putting the new element. So here's how it's going to work. If our sorted array element J, so the element that we're looking at, is larger than or equal to the new value, we've found our place where we're going to put the new value. So typically, like if it's larger, we have found like the element afterwards. So we're going to put the new value there and then push everything over. But also if it's equal, that'll be fine. Like if we get two 11s and we find an 11, well, we're going to drop in the new 11 and then push everything from 11 afterwards over. So if the element we're looking at in the sorted array is larger than or equal to the new value, what we're going to do is we are going to make our sorted array become equal to insert sorted. We're going to pass it the sorted array. We're going to pass it the value we want to insert, and we're going to pass the position that it's going in. Now, after we're done this, we don't need to look through the remainder of the sorted array because we've already found our insert position. So I'm going to put a break here. The other thing that I want to do here, I don't think this is lining up. Something's just slightly off. Okay. The only other time where we have found a position is if we've gone all the way to the end, but we haven't actually found a larger value. So essentially the value that we're putting in is the new largest value. So I'm going to put an else if j equals I minus 1. So this tells us that we are on the last iteration. because j will grow until it is 1 less than I, essentially. So this is our last iteration. What we're going to do is we are going to make our sorted array get the value of insert, and we're going to send it the sorted array and the new value. Because remember, we made that other version that just drops it at the end, and because it has 2 parameters instead of these 3 parameters, it'll know which one to activate. And then we'll put our break here. So, did it work? Let's find out. So I'm going to run the program. All right, what happened here? So sorted array, I feel like I called it new array. I'm sure you caught that as you were programming. And then I just have to return our sorted array here. Return sorted array. And we should be good. All right, did it sort the array? Yes, it did. Start to finish. Okay, great. So just to get a sense of what this is doing, I'm also going to put in here, I'm going to print nums, our sorted array, just so we can get a visualization of what's happening. Okay, so essentially what it does is our first element is 65, and then it adds in the 25 at the beginning, and then the 39 goes here. Now, this is where I have this condition where also if it equals. So what happens is this 39 finds that it doesn't go here, and then it stops here and, or I guess stops here, drops the new 39 here, and then pushes the old 39 and the 65 over. So that's kind of a good visualization so that you can see how that works. So this is a lot more efficient than bubble sort and easier to understand, but you can see as it's easier to understand what it's doing, the programming is a little bit more complex. And this is sometimes just the case or the way it is with algorithms in computer science.